I'm still delighted to introduce Pierre-André Chiappori, who's at Columbia University and apparently stranded in Paris thanks to the wisdom of the INS, which once again wants to protect America from exceptionally talented people. Okay. So without further ado, the floor is yours. Thanks so much.
Thank you so much. So I'm going to talk about inequality, and in particular, I'm going to talk about inequality within the family. So what I will try to convince you of is two things. First of all, there are plenty of very interesting issues there from a conceptual point of view, and we're going to talk of some of them. And on the other hand, there are very interesting empirical issues. One of the main problems with inequality within the family is that there are many things that we don't observe. We don't observe some of the consumption, in particular, when people share consumption, we don't observe that. And in addition, even when we do observe, like when consumption are public and I can observe the quantity that everybody is observing, I don't observe preferences, so I don't observe how much each person cares about that. Now, the surprising thing is that despite the fact that I cannot observe, there are plenty of things that I can recover if I'm using the right theoretical tools. That's exactly what I'm going to talk about. My presentation will be in two parts. The first part, which will be before the break, it's, as you see, it will be about concepts, about model, and about empirical estimation. And the second part will be about a more general equilibrium point of view, the question being there, where does those inequality come from, and can we model the generation of those inequalities from an equilibrium perspective? So let me start with family inequality, and first of all, why do we care? Why do we care about what's going on within the family? Now, you must remember that in the background there is one of the oldest problems of microeconomics, which is how do we compare family of different size? And that's quite important from a welfare point of view and also from a policy point of view. Now, this is the question that I would like you guys to keep in mind for all the class. Assume that I'm thinking of creating a benefit and the benefit is being tested. So the benefit is targeting quite, quote, poor people, and I have a definition of poor people. My definition is something like, say, the income, I'm looking at couple, and I will say that the couple should receive the benefit if their annual income is less than $15,000 a year, okay? Now, what about singles? What should be the threshold for singles? Quite intuitively, it should not be half of that. If they are public good, if they are economies of scale, it's a bit harder to live as a single with 7,500 than as a couple with 1,500. But how can I assess exactly the amount that I should put? How can I compare family of different size? Those are questions which are deeply linked with what I'm going to say, and at some point we're going to talk about those questions as well. So that's in the background. Now, the new problem that's the core of the topic today is what can we say about intra-household inequality? And let me start with an example to convince you that it is actually relevant, and it's very easy to make, if not false, at least misleading statements. So the basic idea is, at the end of the day, we're interested in equality, but it's not inequality across families. We're interested in inequality among people. In other words, think of a society in which families are all identical, but within the family there is a huge amount of inequality. Like, men receive much more than women. You would not call such a society equal. That's the background. Now, let me take a very simple example. Let me consider a society consisting of only two couples. One couple has an income of 10, the other has an income of 11. Now, as you see on the blackboard, the inequality is not very large. The usual way of one way of computing is the tile index. I suppose you will spend a lot of time looking at the different indices, but the tile index is a quite convenient one. The tile index, you got the definition here on the screen. It's 1 over n being the number of people, and then you add you take for each per person the income, you divide by the average income of the population, you multiply by the log of the same ratio, and you add up over the whole population. If you do this computation, you find a very small number. You have two households, so the average income per household is 10.5, so I have 10 over 10.5 log 10 over 10.5. Here I have 11 over 10.5 log 11 over 10.5, and I have this small number here. Now, here I'm using inequality across household. I could think in terms of inequality across people, in which case I will say, well, in the first household, there are 2 people, each of them has an income of 5, so it's add up to 10. The average per capita income in the economy is 525, and I'm doing so the same computation. Note that I find exactly the same numbers. That's a nice property of the tile index. It's stable by this kind of decomposition. Fine. Now let's put some action in this economy. One of the couple divorce. Couple 1 divorces, and after divorce he gets 7, she gets 3. So how do I compute the inequality? Well, I could say now I have 3 households, and I compute 1/3 of the average, or I could say I could put a double weight on the one that has not divorced because there are 2 people, which is equivalent to considering that there are 4 people in this economy. The results are not exactly the same, but what you see is a huge increase in the inequality. So in that sense, if I'm looking at those kind of computation, I would say just because of the divorce, the inequality has been increasing a lot. Actually, it has been multiplied by a factor 40. My basic claim here is this conclusion is absolutely unwarranted. There is no reason to believe it's true. And there are 2 problems with this computation. When I did the weighting, so I took a couple that was married. Each of them, the total income was 11, and I assumed that the income of each person was 5.5. When I'm doing this, I'm making 2 assumptions, and both of them are debatable, and actually both of them are very strongly contradicted by empirical estimation. The first assumption is that individual incomes add up to family income. So whatever she gets plus what he gets is equal to the total income. If you think about it, if they are public good, if there are economies of scale, you would expect that what he gets plus what she gets could add up to more than the family income. And that's the first aspect that we're going to spend some time on. And the second one, which is even more shocking in a sense, is that when I want to find out how much each one is receiving, I just divide by 2. So I'm assuming that each of them gets an equal share. As I said, the assumptions are really debatable. The first one is what I said. The second one, it's completely not justified. From an empirical point of view, I'll come to that later, but all the empirical evidence we have tell us that there is a lot of inequality within the household. From a theoretical point of view, there is no reason to assume that the distribution of resources is equal. Actually, think of any kind of very simple model in which there is bargaining or whatever. If the status quo situation, if the threat point situation is one in which he would get 7, she would get 3, it's very unlikely that when they bargain, they will end up with the same share. Probably, depends which concept you're using, depends how you model it, but probably you will get more than she would. But of course, that matters a lot, because if, just for the sake of example, if you assume that the initial allocation was, instead the 10 was distributed in such a way that he would get 7 and she would get 3 while they were married, and same with the other one, it means that the initial inequality was much, much higher than my computation indicates. What this example, which is a bit extreme, tells you is that that's an economy in which we don't see much across household, but if there is a lot going on within the household, it's something that we missed, but that might be crucially important. So, first question, what was the initial inequality? If you assume equal sharing, of course you will find that the inequality is low, but you have no reason to assume that. The example is naive, but you see a lot in the empirical literature that implicitly makes this assumption, which makes it quite dangerous. Look the following claim. I'm not going to tell you where I picked up the claim, but it's in a published paper and a quite influential paper. Look at the numbers like this. Look at this statement. In 2007, 5.8% of all people in married family lived in poverty. My claim is this statement is wrong, or at least is unwarranted. The one statement you can make is 5.8% of people live in families in which the total income is below the poverty level. But within this household, how many people are in poverty and are not depends on the intra-household allocation. And if you don't look at the intra-household allocation, you cannot make a claim like this. This claim entirely relies on the assumption that the sharing is equal, and as we saw, that's an assumption that's difficult to make. Now, at the end of this first half of the talk, I will give you estimates in a beautiful recent paper by Lubel, Pendacourt, and Dunbar about Malawi, in which we're going to see how they do that, but they can decompose the income, the intra-household inequality within poor families in Malawi. So we're talking about development economy, we're talking about very poor families, and you will see that the picture that you get when you look at what's going on within the family is completely different from the one when you just aggregate the family and count how many of them are below the poverty line. Okay, that's the motivation. We do care about what's going on within the household, and there are two types of problems, as I said, conceptual problem on the one hand and empirical problem on the other hand. So let's start with the conceptual problem. How do we deal with intra-household allocation? How do we deal with public good, with economies of scale? How do we deal with this idea that maybe individual income add up to more than household income? A deeper question: what relationship between preferences when single and preferences when married? You know, in a sense, we're comparing the welfare of people by themselves to the welfare of people who are married. We need to take a stand on how the preferences vary, and you will see that it's a conceptual question, but it will come big time whenever we try to take that to data and talk about empirical estimation. It's settled a long time ago. We're going to get back to them, and you'll see that they will be quite interesting. So that's a conceptual problem. Empirical problem, what can we identify? Of course, we want to talk about intra-household inequality from a conceptual point of view, but if we have beautiful concepts that cannot be observed on real data, that's not very useful. So what can we identify? And I will be quite exhaustive about this. But the point is, you need a model. This is a situation in which you cannot do without theory. If you want to understand something that's going on within the household, you need a model about what's going on within the household. And here, during this talk, I will explicitly consider one type of model, which is the so-called collective model, which is what I'm going to present now. You have questions so far? That's my introduction. That was my introduction. Okay, let's move. This is my general roadmap. I'm going to start with some basic concept, then I'm going to talk about identification. I want to talk about empirical results, then we'll have the break, and then the second half will be about the equilibrium perspective. Let me start with the basic concept. So the collective approach, now I don't know to what extent you're familiar with the collective approach, but the basic ideas are very simple. There are essentially two basic ideas. One is, if you have different people, they might in principle have different preferences. So the one thing you don't want to assume is there is one utility which you call the utility of the household, which summarizes everything. If you have two people, you have two utilities, and then at some extent you have to talk about the decision process. And the second assumption is, what are we going to assume about the decision process? Now, you may want to be precise. You may want to say it's going to be bargaining, and it's going to be Nash bargaining, and let's talk about what the thread point could be, or it could be Kalais-Morodinsky or any kind of other concept. The collective approach tells you, let's try to be a bit more general. We assume just one thing, namely that the outcome is efficient. So in particular, any bargaining model, at least under symmetric information, will give you Pareto efficiency, but there are plenty of other models that have been used. Equilibrium model a la Grossbart-Shechtman, models based on the so-called separate spheres in which people bargain using the non-cooperative as a background. Many models have been used that exactly look at this. And by the way, the standard approach, which I would argue is not appropriate, which is the so-called unitary approach, in which you assume that there is just one utility, is a particular case of this. If there is just one utility, the outcome will be efficient, I would say, by definition. I'm assuming Pareto efficiency, that's an assumption. By the way, one thing that's not completely clear is that it's a testable assumption. You might think that any kind of behavior can be reconciled with efficiency if I'm just using the right references. That's not the case. It's testable. It has strong testable implication. So we could talk about the justification. Why do I assume? What should we assume efficiency instead of, for instance, non-cooperation? And essentially, we can think at least of efficiency as a benchmark. Their justification, like, you know, if people are rational, they should be able to find an agreement so that no money is left on the table. Maybe he will get a lot, maybe she will get a lot. There is a lot of power issue involved here, but at least they should not leave money on the table. A more game theoretic justification would be, you know, it's a repeated game. There are lots of interaction between the husband and the wife. There are good reasons to believe that there is symmetric information. So repeated game with symmetric information, they are a strength that pushes you in the direction of cooperative outcome. It's not always true. It's not always true that it's a repeated game. For instance, some decisions are made once during the relationship. So there may be questions here. Asymmetric information can be discussed in some context. So let's think of this just as a benchmark. The one thing that I want to emphasize is the crucial issue of those kind of model is the notion of power. The one thing those kind of model want to capture is really decided that who has power matters. That if you take two households which are completely identical as seen from the outside, but in one the wife has most of the power, whereas in the other it's the husband, you would expect those households to behave differently. And that's exactly what we want to model. We have good empirical reasons to believe that, by the way. For instance, there is clear evidence, I'll come back to that later, but there is clear evidence that if you give a benefit to the wife, it's not the same outcome as if you give the same benefit to the husband. Despite the fact that the total income of the household doesn't change, and the traditional interpretation of this is really that by giving it to the wife instead of the husband, you're changing the balance of power. That's exactly what this kind of model would like to capture. The good news is, if you're assuming efficiency, there is a very practical and natural way of thinking in terms of power, and those are the Pareto weights. Efficiency is equivalent to the maximization of a weighted sum of utility. And then a translation of a sentence like, in this household, the wife has a lot of power, would be something like the Pareto weight of the wife is very large with respect to that of the husband. You have to be careful. As the way I just stated it, this means nothing because the Pareto weight depends on a particular cardinal representation of utility. So we're gonna be precise about this. But you know, there is this intuition that translating an intuition like this particular policy will empower the wife. The natural translation in a model like this would be, well, look at the Pareto weight, keeping the cardinalization of utility constant, this reform will increase the Pareto weight of the wife. And that's a very natural way of thinking about this. Let me be a bit more precise about the setting. So I have S agents. So I'm talking about any kind of group. During my presentation, I will talk about the family, but this is a context that you could apply to a firm, that you could apply to a village when people are cooperating to share risk. And it's the general way of representing a group when this group is making Pareto efficient decision. So some of the consumptions are public, some are private, Private means that there is the vector consumed by person 1 and the vector consumed by person 2 all the way to S. It might be the case that I don't observe individual consumption. Actually, most of the time I don't. I only observe the sum, which is the total consumption of private good. Let me talk about the notion of distribution factor. Distribution factor is any variable that might have an impact on the respective bargaining power of the husband of the wife, or the respective power in general of the husband and the wife. Let me give you just one example, and I will be more precise later on, but assume that you change the laws regarding divorce, and you make divorce much more favorable to women. Let's say you change the law about alimonies, and you change it in such a way that women are better off. Now, consider a couple who does not divorce. For this couple, the reform doesn't change the budget constraint, obviously it doesn't change the preferences, but it might have an impact on what's going on within the couple, just because it might change the threat point. If you believe in bargaining, that might change the outcome. That's typically a distribution factor. A distribution factor is something that matters only on its impact on the decision process. Now, during all those presentations, actually, in this kind of theory, you put a lot of attention on the decision process. So it's pretty clear that from an empirical point of view, if you have access to any kind of variable that might have an impact on the decision process, you can use it, and this will give you a lot of mileage in terms of identification. So I just call that distribution factors. And lastly, I need to say something about preferences. Now, the most general preferences will be my US of Q, Q1, QS, which means that I care about the consumption of public good, and then my own consumption, and then the vector of consumption of everybody else. And that's very general. It's a bit too general, actually. If you take this kind of model, you cannot identify much. The other extreme is egoistic, which is US of Q, QS, which means that I only care about my own consumption. That might be a bit too restrictive. I mean, there could be altruism in the couple. I could just care about the other person in the family. So the caring solution, which comes directly from Becker, is what I'm maximizing is a utility that depends on my own utility and then on everybody else's utility. But it's much more restrictive than the general form, because there is some kind of separability. So what this is telling you is I may care about my wife's consumption, but only insofar as she cares about it. Assuming efficiency is that the property of the caring model will be pretty close, actually almost identical to the property of the egoistic model. So essentially you can introduce caring at no cost. Why that? Because I'm assuming efficiency. But it's quite easy to realize that if an allocation is efficient for caring utilities, it must be efficient for egoistic utilities. And the idea is very simple. The idea is if it was not efficient for egoistic utility, then I could increase one person utility without decreasing the other person. But then altruism means that that I'm increasing the utility of everyone in the economy, and that would be a violation of efficiency that I assume to start with. Okay, so what do I observe? Questions? Okay, I observe a demand. The demand is the vector of public good and then the sum of private good. It's a function of price. That the notation I might note xi for the total demand and pi for the vector. And efficiency, as I said, simply means that they are Pareto weights such that you're maximizing the weighted sum of utility under the budget constraint. By the way, mu(s) needs not be a constant. In general, mu(s) is not a constant. In general, mu(s) depends on everything. And actually, that's exactly what I'm interested for. I'm interested in the fact that if I change incomes, I might change the respective weight of the husband and the wife. If I change wages, I can change the powers. If I change some of my distribution factors, I can change everything. I could introduce household production. I'm not going to do it here, but it can be done at no cost. Now, we have the basic material. Let's start to talk about inequality within the household. And let's start to think with the very simple case. It's a completely unrealistic case, but it's very simple, so let's start with it. Let me assume just for a minute that in this household we have only private goods. Now I have a basic result, which is stated on the screen, which is the following. Forget about my efficiency assumption. Let me tell you a slightly different story. And the different story is the story of a two-stage process. Stage one, everybody sits at a table, we put the money on the table and we split it. Anyway, the only constraint is we don't leave money on the table. And then stage two, each person has his own amount of money and he or she does whatever he or she wants with this amount of money. This is equivalent to efficiency in a world in which there are only private goods. And by the way, that's not a surprise. It's called the second welfare theorem. Because essentially the second welfare theorem tells you in an economy with only private goods, any efficient allocation can be decentralized via transfers. Now this idea of you put the money on the table and you split it, that's exactly what transfers are doing. Now, of course, now what I call the sharing rule, so let me just take the case in which I have two persons in a household. Everything can be generalized, but it's simpler to deal with two. So what we call the sharing rule is row 1 and row 2 such that they add up to y. So row 1 is what she gets and row 2 is what he gets. The total is the total amount that's available, and what he gets and what she gets could depend on everything. Could depend on prices, could depend on total income and on distribution factors. Now, if I'm interested in inequality, I'm in a very simple situation. If I want to think in terms of inequality, the only thing I need to know is what's the sharing rule. If I can, there is an empirical issue that we're going to talk about later on, which is, can I identify the sharing rule? But if I can identify the sharing rule, inequality is not a problem. I just need to look at the sharing rule, and this gives me a perfect description of the intra-household inequality. And in addition, the sharing rule is in dollar, so it's not an inequality, the inequality is not measured in terms of utility, but there is a one-to-one correspondence between the utility of the person and the amount that the person receives, so it's the perfect measure. So problem solved, except that it's solved in a very special case, which is the case in which I have only private good. So I'm disregarding public good, I'm disregarding economies of scale, I'm disregarding household production and so on and so forth. And those things are essential. Actually, those are the reason why the household exists to start with. It's very hard to believe that the household has nothing to do with the existence of public good, with the existence of domestic production, with the existence of economies of scale, and so on and so forth. So what we're going to do next is we're going to extend this model to two cases. The first one, which will be simpler, will be economies of scale. And the next one, which will be the really interesting one, which is public good. Questions? Okay so far? Yes, go ahead.
So you say that once we obtain the sharing rule, that there's one relationship with a runaway, but do we really know what that relationship is?
You're talking about identification. In other words, if I assume that I know the utilities, if you give me the sharing rule, I know exactly what the welfare will be. There is another question, which is, given what I observe, presumably demand function, can I recover the utilities? I'm going to talk about this. The answer is yes, if you're willing to make the right assumption, and the right assumption are not too demanding, but we're going to spend some time on this. So bear with me a little bit more, and I'll come back to that. Let me start with economies of scale. Let me tell you an assumption which is somewhat hard to swallow, which is somewhat extreme, but you know, we want to think about economies of scale in a pure way, so let's try to make an assumption in which the only thing that matters are the economies of scale. Here is the assumption that I'm going to make. If you take people are characterized, so first of all commodities are private, so if you look at my utility, it only depends on the vector of private consumption. I'm going to also assume, for the moment, that my utility is exactly the same whether I'm a single or I'm married. So the marginal rates of substitution between any two commodities is something that's intrinsic to my personality, and the fact that I'm single or married is not affecting those stuff. However, one thing that's that's changed by the fact that I'm living in a couple is that there are economies of scale. That there are, so for instance, there is some fixed time used for production, preparation, things like this. So for instance, if you think of food, there is a fixed cost represented by the fact that I need to buy the food and then I need to cook it, and the fixed cost is pretty much the same if whether I buy for one person or two person, and whether I cook for one person or two person. So those are the notion of economies of scale. Let me take something which is a little bit more debatable. Think of a car. If there is a car and I'm using the car and my wife is using the car, but we never use it together, the car is a perfectly private good. There is my usage and there is my wife's usage. But if most of the time we're both in the car, there are economies of scale. And there are economies of scale in the sense that it's less costly. In a sense, you see that there is a benefit in living together with respect to two persons living single. Two single would need two cars. If most of the time my wife and I travel in the same car, we just need one car. So that's the kind of thing we want to capture. And the simplest way of capturing this is to say, which again, it's really the idea of domestic production dating back to Becker. My preference depends on something that I consume, but this Q which I consume is not what I buy. What I buy is a vector R. So the budget constraint is in terms of R. And then there is a technique, a production technique which links what I'm buying with what I can consume. It's really the idea of household production. This A in principle could be nonlinear. In practice, we're going to assume that it's linear. And most of the time for empirical application, we're going to assume that it's diagonal. Now, look at this equation here. With a diagonal, it tells you that the amount that of commodity I that I'm buying is equal to some AII times the sum that's consumed. Now, assume that the commodities are completely private. Then, essentially, I is exactly equal to 1. What I need to buy is whatever my wife is consuming plus whatever I am consuming. Assume, on the other hand, that take the car example in which we always ride together. In that case, this AII would be 1/2. Because the total usage that I'm going to get will be equal to my usage, and it will also be equal to my wife's usage. And in general, this AII guy will be anything between 0.5 and 1. If it's close to 1, there is no economies of scale. If it's close to 0.5, there are plenty of economies of scale. And the question is, can I identify those from data? Now, this might remind you of something which used to be hot when I was a student, which has been less and less interesting, in which people have been less and less interesting over the years, but I think it's still crucial, which is the notion of equivalent scale. How many of you are familiar with the notion of equivalent scale? Okay, not everyone. Let me remind you what an equivalent scale is. What's fun here is that it's an extremely important notion from a welfare, from policy point of view. It's crucial and it's used basically every day by applied economists. From a conceptual point of view, it's a complete disaster. Bad economics at its worst. Now remember, it's always the same question. I have a couple with an income capital Y. I want to compare that with a single. And the question is, which income, small y, should I give to the single, would the single need to be in the same situation, quote unquote, as the couple? And of course, in the same situation, I put that between quotation marks because giving a definition to this sentence is exactly what this theoretical problem is about. Okay? Now, the definition that I'm giving you here is the standard definition of an equivalent scale. Essentially, the y is such that if the couple, if you're receiving the income capital Y, is exactly as well off as the single receiving the utility small y. And you immediately see that there are plenty of problems with this definition. First one, I need interpersonal comparison of utilities, which is something that's hard to do. It's not that I need to compare the utility of person A with the utility of person B, which by itself is problematic. I need to compare the utility of person A with the utility of a couple. So it's not only interpersonal, but it's comparing utility of a single with the utility of a couple. And by the way, even worse, which means that I need something like the utility of a couple. I don't know what the utility of a couple is. I know that I can think of a couple as 2 persons and each of them has a given utility function, but what's the utility of the couple? It could be the weighted sum, but then the weighted sum will be price dependent, and definitely I cannot compare it to the utility of a single. So from a conceptual point of view, it's absolutely not clear how I can justify this concept, and in addition, it's not identified. So there is an old paper by Blundell and Lubell that shows that actually it's not identified in a very nasty way. You give me any numbers you want, and if I have a data set that's compatible with consumer theory at all, it's compatible with a particular version of the equivalent scale in which the equivalent scales are exactly the numbers that you give me. So it's very strong non-parametric absence of identification. So as I say, this is bad theory in a sense. You're using concepts that are not even defined, the utility of a couple, or you're using comparison that in principle you cannot do. On the other hand, it's crucial, because you cannot evade the question, what's the poverty level for a single if the poverty level for a couple is 15,000? Here is the notion that could replace the notion of equivalent scale, and it's something that we propose in a paper with Martin Browning and Arthur Lubell. It's the notion of indifferent scale. The new question is, Y will be the amount that the person, when single, will need to be as well off as the same person when he or she was married. So note that here I'm not comparing utility across people. It's the same person in two different states. I still need something like an assumption like the utility when you're single is the same as the utility when you're married. So I'm comparing the utility of a person when single with the utility of the same person when they are married. There is an assumption here. On the other hand, it's very hard to avoid, right? Because if you want to compare situations between singlehood and marital and being married, you need something must be comparable between them, but it's really minimum. You don't need anything like the utility of a couple. We have something like the utility of each spouse. The only problem is, can I identify the utility of each spouse? But the answer is yes, everything is non-parametrically identified. Now in the reading list, there was the paper by Martin Browning, Arthur Lubell and myself, and there is another paper by Dunbar, Lubell and Pendaker, and both of them, all the theory, I'm just giving you the result, the detailed theories in those two papers, and if you're interested, you're most welcome to look at this. Essentially, here is how it works. See, the basic intuition is the fact that there are economies of scale. What this is doing is changing the prices. In other words, remember this A here is the transformation matrix. A prime being the transpose. I'm changing the prices in such a way, the prices that people will use is the matrix A multiplied by the market price. Now this is linear algebra, but the economic intuition is very easy to understand. Assume there are no economies of scale. So what I buy is what I consume plus what my wife consumes. Then the price inside the household is exactly the same as the market price. Take the other extreme in which there are huge economies of scale. So my A is 0.5. Essentially, the fact that I'm living in a couple means that the price of those commodities is de facto divided by 2. The amount I have to pay is just 1/2, and what the amount that my wife has to pay is just 1/2, because when you add those two stuff, you get the price of the total consumption. So then we can write down the individual consumption with a sharing rule, using the fact that people don't use the same prices, and the basic result will be something like this. If I identify utility function from the demand function of singles, then looking at demand function from couples, I can identify the technology. In that sense, the model is non-parametrically identified. Note that I still need the strong assumption that every commodity is private. Questions about this? Now, at some point at the very end, I will give you a few empirical applications, and in particular, the paper by Dunbar, Lubell, and Pendaker is using exactly this technology, actually a milder form, a similar technology, but relying on weaker assumptions to elicit intra-household allocation in developing countries. Those are the Malawi data, and you will see that you can get a lot of mileage using this kind of technology. If it's okay, next I'm going to move to public goods. Now, here is the name of the game. I want to think in terms of inequality in a world in which there are public goods. Just to get an intuition of what the problem is. In general, first of all, we know that public goods are important. Actually, public goods are a large fraction of the consumption of a household, especially in the standard way of modeling children, at least young children, is as public goods. So the expenditures on children are something that increase the utility of the child, and the utility of the child enters both the utility of the mom and the utility of the dad. So public goods are really crucial, and if we think in terms of human capital formation and so on and so forth, investing in children, at least at the beginning, we can think of it as a public good within the household. One crucial thing is we don't want to assume that both parents have the same attitude toward those public goods. We don't, it might be the case, but we don't want to assume it. Maybe the data will tell us that it's the case. But we want to open the door to the possibility that the two parents don't have the same valuation of the value of education to children. By the way, there is good empirical reason to believe that. There is a paper by Esther Duflo about South Africa that shows that if you give the money to the grandmother instead of the grandfather, the impact on the well-being of granddaughters is completely different. So this strongly suggests that the way grandmother value the welfare of their granddaughters, which is a public good, is quite different from the grandfathers. Now, what about inequality with all this? I want to take into account the fact that when I spend something on the public good, it does not enter the utility of the husband and the wife in the same way, not necessarily. So conceptually, how do I measure utility? How do I measure inequality in a world like this? What I'm going to do is I'm going to show you three ways of addressing the problem, and I will argue that the first two are not convincing, but the third one might be convincing. This is brand new stuff, so your comments on it are welcome. Let me start with a natural extension of the sharing role, which is called the conditional sharing role. So it's the same story of a two-stage process, except that it's slightly richer than before. So here is the story. Two-stage. First stage, we sit at a table and we make two decisions. One is, how much do we spend on the public good? That will take some of the money. And the money which is left, how do we allocate it across people? That's stage one. At the end of stage one, the public good has been decided upon, and each person has a given amount that he or she can spend on his or her private consumption. That's exactly what this definition is telling you. Now, any efficient allocation, you can decentralize it using this kind of two-stage process. Be careful, the converse is not true. It's not true that any allocation that you get using this two-stage process would be Pareto efficient. That's because there must be a relationship between the amount of public good that you're buying and the distribution of the remaining money. And the condition, which is known as the Bowen-Lindahl-Samuelson, is something like the redistribution should be such that the sum of marginal willingness to pay for each commodity, given the amount chosen, is equal to the price of that commodity. In terms of inequality, we could look at the allocation. We can try to mimic exactly what we did with private good and look at this conditional sharing rule, which is the allocation of the private good. But here, it's hard to say that this is a good estimation, a good evaluation of inequality, because we're missing something. We're missing the public consumption. And you see what's wrong with this. Assume that most of the income of the household goes on public consumption, and assume that the wife cares much more about the public consumption than the husband. You might be in a situation in which, in terms of private consumption, she does not get much and he gets a lot. That's not very important. The important thing is that most is spent on public good and she cares a lot about the public good. So you wouldn't like to conclude from the fact that her private consumption is much less than the husband that there is inequality in favor of the husband. You want to take into account the public good. You following me here? So this has been used, this is useful from an empirical point of view, it has been used, but it's not, in terms of inequality, it's not exactly what we want to do. Second thing, Lindahl prices. How many of you are familiar with the notion of Lindahl prices? Okay, there is a general result about decentralization. So here, there is the whole literature about how can you decentralize efficient allocation. So when all commodities are private, the second welfare theorem tells us you want to decentralize efficient allocation, just let the market operate and just redistribute. When they are public good, things are a bit more complex, and there is a result which is the following. You can always decentralize an efficient allocation within the presence of public good, but you need to charge individual specific prices for the public good. In other words, there is a duality between private and public good. Private goods, everybody pays the same price, but people buy different quantities. Public good, it's the opposite. Everybody buys the same quantity because there is a quantity of the public good which is purchased by the household, but people pay different prices. Now, the feasibility constraint on the private goods side is that the sum of individual consumption is the total amount purchased by the household. The efficiency condition on the public goods side is that the sum of the interpersonal prices is equal to the price of the public good. And actually, the personal price of the public good is exactly what we call the marginal willingness to pay, or the Lindahl price. So in other words, now I have a decentralization in which I'm distributing Y into those row star A, which are called the generalized sharing rule. They add up to Y. And then I'm facing every person with a set of personal price. And then I'm telling everyone, buy whichever quantity you want in terms of private and public consumption, subject to the fact that you cannot spend more than the amount that you've been allocated. Now, if the personal prices are the equilibrium prices, everybody will ask for the same quantity of each public good, but people will pay personal prices. Now, the cool thing is that the personal price is exactly reflects, when I was saying that people care differently about the public good, that's exactly what's captured by this notion of a Lindahl price. This is an old literature. This is the welfare literature of the 50s and 60s. So in a sense, it's a renewal, a revival of old concepts. Now, well, that's my next question. Would you say that if I want to have a good idea of inequality, I just need to look at those row stars that are here? They add up to Y, and in a sense, that's the amount that people are gonna spend. So can I summarize the inequality by just looking at those row stars? And I will argue that it's much better than the previous one, but it's still not perfect. There is something that they're missing, which is the following. Let's assume just for a minute that the numbers are such that the row star of the husband is exactly equal to the row star of the wife. So they split equally. But the personal prices are quite different. The wife cares much more about the public good, so she pays much more. That's exactly, the personal price reflects the marginal willingness to pay. And when I'm saying the wife cares more about the public good, it means that her marginal willingness to pay is higher. Now, this is a strange concept of equality, right? If I just look at the row star, I would say there is no inequality because they get the same amount. Well, they get the same amounts, but with this amount, they're consuming commodities and are not paying the same price for those commodities, and the wife is paying a higher price. So I would say in that case, there is something wrong with this. I'm not taking into account the fact that the price differ, and that if you have the same income, but you have to pay a higher price for a given commodity, in the end you're worse off. And I'm forgetting this. So this, I would argue, is better, but it's still not the solution. And that's what I would call the solution. See, the problem with those Lindahl price decentralization is I'm looking at an amount, a monetary amount, but people are facing different prices. Well, the natural answer would be, let me renormalize the utility with respect to the same prices. Now look, if you look at this equation here, the right-hand side is the utility that I get, given that I'm receiving this row star, and given that I'm paying the personal price PA. The left-hand side, it's the amount that I would need to get exactly the same level of utility if instead of being faced with the personal price PA, I was faced with the market price. So I'm just renormalizing utility, facing everyone virtually with the market price. And this is what we call the monometric welfare index. And here you're taking into account the fact that people pay different prices. So it's the utility that they will need if everybody was paying the same price. Now, which price doesn't really matter, but it's sort of natural to take the market price. Now, those are new concepts. It's a bit complex. Let's look on an example. And I think the example will be quite clarifying. So I'm taking the simplest possible utilities. I'm taking Cobb-Douglas utilities. There are only two commodities, a private one and a public one. I have Cobb-Douglas utilities, the coefficient add up to 1. And I'm going to maximize a weighted sum of utility, but the weight's going to be 1. So I'm going to maximize just the sum of utility. So I'm putting a lot of symmetry between the husband and the wife. However, there is one thing that will be asymmetric. I will take this alpha to be 2, and I will take beta to be 1/2. So in other words, what I'm saying is, they have different preferences in the sense that the wife puts twice as much weight on the public consumption than on the private one, and the husband is the opposite. He puts twice as much weight on the private consumption. Okay? Now, for the moment, I'm using the general formula alpha and beta, but remember that at some point alpha will be 2 and beta will be 1/2. You can compute the indirect utility. You can compute the demand as a function of the Pareto weight. The nice thing with the collective model is that it's very tractable. You can compute everything. And you can compute the 3 concepts, which is the conditional sharing rule, the Lindahl prices, the generalized sharing rule, and the MMWIs. Those are formulas, but now let's look at numbers. And again, I'm assuming that the Pareto weight is 1, and I'm taking alpha equal to 2, while beta is equal to 0.5. You do the computation, and what do you find? You find that 50% of the household income is spent on the public good. And of the remaining 50% of the income, which will be spent on the private good, 2/3 goes to the husband, 1/3 goes to the wife. Now my question is, how much inequality do we have in a household like this? And let's look at the 3 concepts in this particular example. So the first concept, the conditional sharing rule, only looks at the private consumption, and this concept tells you there is a lot of inequality because he consumes twice as much as she does in terms of private consumption. And C, I'm saying there is a huge amount of inequality, and that's not right. I'm overestimating the inequality because I'm completely neglecting the fact that 50% is spent on the public good, and she cares much more about the public good than he does. Okay? So in a sense, I'm forgetting something which is very important for her and which reduces the inequality. Next concept, the generalized sharing rule. You do the computation and you find that in that case, my row stars are equal to half the income. So here the story is, I'm splitting the income 50%, and they buy whatever they want. But of course, remember, she cares more about the public goods. So when you compute the Lindahl prices, you find that the price she pays is twice as much as the price that he's paying. Now, if you just look at this, you would say there is zero inequality here. They have the same amount. Well, they have the same amount. They pay the same price for the private good, but she pays twice as much for the public good. So now I'm underestimating the inequality. And what would the MMWI, the Monometric Welfare Index, well, essentially here the computation, they are very easy to do. And what I find is 2 things. First of all, there is some inequality, and this inequality is simply reflecting the fact that her utility is less than you would expect just because she pays more. In particular, her utility is less than what he gets because she pays more for the public good. Another interesting thing is that those 2 guys now do not add up to Y, they add up to more than Y. But you know, that's exactly what I want to capture. I want to capture the fact that because they're public good, there is a gains on welfare with respect to what they could have done as single. Note one thing, there is something that I did not say, which is the utility that I showed you, the Cobb-Douglas utility, those are the utility of the husband and the wife when they are married. One statement I did not make is they are also the utility when they're single. I don't need this assumption. Let's make now this assumption. Let's assume that it's the same utility. Now I have a very simple translation of what's going on, which is this is the income that she will need as a single to get the same utility level as she would get being married, right? Because that's the amount she will need to get exactly the same utility if she was going to pay the public good at the full price. She would not buy the same quantity of the private and the public good. Since the public good is now more expensive, she would buy less of the public good, more of the private good, but that's the amount she would need to reach the same utility level. Now, coming back to the previous discussion, I can make this statement if I assume that the utility when you're married is the same as the utility in the single. You may or may not willing to do that. If you're willing to do that, then you have an interpretation. The concept is valid no matter what. Do you have questions about this? Yes. That's a very good question, and the short answer is yes. You can extend that to production, and I'm not going to do it lack of time, but that's a very good point. Now, let me just say one thing about production. The crucial thing about production is when production takes time. How do I evaluate the time of the husband and the wife? And there is a natural solution for doing this, which is I just use the wage. Well, it's a natural solution if they are both working. If one of them, for instance, the wife, is not working, then I should use the shadow wage. So in terms of identification, there are very interesting aspects here, and actually we're working a lot on this. But take of the simple situation in which both the husband and the wife are working, then I can model the production. I can use the standard production function kind of approach, and then I can value the input to the production function, which is the time, which is leisure, and then the private commodity could perfectly be leisure in this kind of model. So it can be extended to production function. It requires some care, and it can be done, but I don't have time to do it now. There was another question? Yeah. Yes.
So, I was thinking, how does the free rider problem enter in this case? So the husband could basically free ride on the wife's investment in the public good, right?
I'm assuming efficiency. So I'm assuming away the free rider. Remember, this is a model in which they make efficient decisions. So in other words, at some point they sit on a table, they decide what to do, and it's not the case that they spend less than they should just because the husband tried to cheat. It may or may not be a realistic assumption, but that's... Now, by the way, here is an interesting research program. Develop an alternative model of decision making in which we don't have this kind of efficiency, for instance, in which the free rider problem could be there, and then let's try to see what's testable or not. This has not been done. It could be very interesting. What has been done, to be complete, we have a few models in which we try to model the household behavior in a context in which people make decisions about public good in a non-cooperative way. So it's essentially private provision of the public good, which is basically the same as the free rider problem. The surprising stuff is that then you have very strange predictions which are not don't fit empirical data that well. For instance, in this kind of model, you have income pooling. You have for some values of the parameter, you have open space for parameters in which you take $1 away from the wife, you give it to the husband, and it doesn't change anything to the aggregate demand for the household. So I tend to think that empirical evidence that we have go more in favor of the efficiency model, but in the end, it should be an empirical question. But the answer to your question is really, I'm assuming that way. I'm assuming efficiency. Okay. Well, let's talk about identification, right? And now, the one point I want to make, I have something like 30 minutes before the break, is that from the conceptual point of view, the private commodity case is the easy case, and the public good case is the more complex. We need to think a little bit. We need to define new concept. From the identification point of view, it's just the opposite. The public good case is very easy. The private good case is much more complex, and in particular, we're going to see some paradox, which will take us back to the question, are we interested in inequality of income or in inequality of welfare? So let's try to do that. The first thing, this is a result, and you have to take my word on this, It's published, so you can go to a paper by Ivar Ekland and myself in Econometric 2009. But so first of all, let me tell you what the game is about. Let's assume that I observe demand functions, right? So I have this couple, and I observe the quantity of each public good that they're buying, and I'm observing the total quantity of each private good. I'm not observing how much each of them is consuming, but I'm just observing the total quantity that they are consuming. So I'm observing the household demand function. And the question is, what can I identify? Now, first of all, if I don't make an over-identifying restriction, I cannot identify there are a bunch of different models that will give me the same demand function. So I need an over-identifying restriction. And the over-identifying restriction that you got in the statement is what I call one exclusion restriction per agent. This means the following. If I just have a couple, there must be one commodity that's consumed exclusively by the husband and one commodity that's consumed exclusively by the wife. But that's the only thing you need. You may have 30 different commodities. If one of them is exclusive for the husband and one of them is exclusive for the wife, I can identify. It's generic, so you can always construct some kind of knife-edge situation in which you cannot identify, but they are not robust to perturbation. So you have this kind of generic identification result. What can I identify? I can identify what's welfare relevant, which is the collective indirect utility. Now, the collective indirect utility, let me give you a definition, and that's very simple. So remember, there is this decision process. So I have two utilities. There are prices, there is income, there is a decision process. At the end of the decision process, she has a consumption, he has a consumption, she has a utility, he has a utility. So at the end of the day, her utility is a function of the prices, the income, and everything that can have an impact on the decision process, including the so-called distribution factors. And in the same way, his utility is a function of everything. So it's something like an indirect utility, but it's not the standard indirect utility because it depends not only on the preferences, but also on the decision process. So it's a sort of summary, reduced form of everything that has been going on within a household. So again, this collective indirect utility is a function of prices, income, and distribution factor, anything that can have an impact on the decision. And the result tells you this is what you can identify. If I can observe behavior and I have my exclusion restriction, I can identify those guys. Those are the welfare relevant concepts. But then the question is, once I identify the collective indirect utility, can I recover the direct utility? Can I recover the decision process? Can I recover the Pareto weights? Can I recover my MMWI indexes and so on and so forth? So what's the link between the theoretical concept of the collective indirect utility and the kind of thing that we're used to look at, namely the sharing rule, the amount consumed by each individual and so on and so forth? And let's start with the public goods. And as I said, in the public good, piece of cake, look at the relationship which is here. The indirect utility, the indirect utility of the wife, that's a function of the price of the public goods and the total income. And it's also the direct utility of the quantity of the various public goods. And note that she's not consuming commodity 2 and he's not consuming commodity 1. That's my exclusion restriction. So it's very easy to convince yourself that if I can identify VA, given that I can observe Q1, Q3, Qn as function of prices and income, I can identify UA. In a sense, it's just a change of variable. Not only I can identify, but I have over-identifying restrictions. And that's true. Actually, what happens here is that utilities are ordinarily identified. Of course, you can only identify preferences. You identify up to a cardinalization. The Lindahl prices are exactly identified, the MMWIs are exactly identified, and so on. So, in a nutshell, when you have only public good, the identification problem is very simple. You give me the demand function. If I have this kind of exclusion restriction, everything is identified. Now, let's look at the private good case, and the private good case is much more complex. The result tells you the collective indirect utilities are identified. That's true. That's true in general, whatever the framework. The question is, if I have the utility level, so essentially, what I can identify is the utility level that each person is going to reach at the end of the day. And you know, if I'm interested in welfare comparison, that's the only thing I care about. If my question is, I'm thinking of some policy reform, is it going to increase or decrease the utility of the wife? Is it going to increase or decrease the utility of the husband? That's the only thing that I need. But I'm interested in inequality. And I'm interested in inequality as measured in dollars. So I might be willing to recover something else, which is, for instance, the amount spent, which is the sharing goal. And now now I have the question, if I observe the collective indirect utility, can I recover direct utilities, and can I recover the decision process as summarized by the sharing goal? And I'm going to do that first in the situation in which all commodities are private, and the situation in which they are private and public commodities, it's pretty much the same logic. You can up to something. So let me try to be precise, and that will be the end of my of the theory part. Then I will give you some empirical application. Let me take the very simple model in which I have only 3 commodities. Remember, for my identification, I need exclusivity. So 1 is consumed exclusively by member A, and 2 is consumed exclusively by member B. And 3 is consumed by both, but I don't observe the individual consumptions. By the way, this could be a labor supply model. In the initial literature, the first paper doing this, you were using this framework, and those were labor supply, but it could be consumption, it could be anything. What do I observe? I observe individual demands. I observe the demand of commodity 1, which I know is by the wife. I observe the demand for commodity 2, which is by the husband, and observe the demand for commodity 3, which is the sum, but I cannot observe the decomposition. I want to recover the utility of the wife, the utility of the husband, and the sharing rule. You following me on this? That's the nature of the problem, okay? What I'm gonna say is the following. Let's assume that I have a solution. So assume that I have a U bar A, U bar B, and rho bar, such that if I'm maximizing U bar A under the budget constraint corresponding to rho bar, and I'm maximizing U bar B under the budget constraint corresponding to Y minus rho bar, I get exactly the demand that I observed. So assume I have a solution. My claim is I can construct an infinite number of alternative solutions that all depend on one variable, which is this K here. So let's look at how I construct those variables. So I'm starting from the rho bar and the U bar, and I want to construct the rho K and the UK. Regarding the allocation of resources, it's very simple. I just mimic what I used to do in my rho bar solution, except that I always give K additional dollars to the wife, which are withdrawn from what the husband is getting. That's the way I construct my new allocation. So I have to construct new utilities, and the way I construct the new utilities is I'm saying, well, what's written here is essentially the new utility that they get with this new rule is exactly the same utility they used to get in the old rule, taking into account the fact that they receive less now than they used to. So in other words, in my K world, their utility, the utility that I will get with this K additional unit is exactly the utility that I would have got in the initial U bar solution without those K units. That's what this is telling you. For those of you who prefer a graphic representation, the initial solution U bar is in black. What I'm doing is whatever the price, so the price will be the slope of those lines here, and the distribution will be the intercept. Systematically giving K less units to the wife, so to the husband, sorry. So I'm shifting everything down. I'm shifting the amount that he received, but I'm also shifting his preferences. So the construction is what it is, but in pure English, it's pretty simple. I'm giving him K less units, but I'm changing his utility in such a way that he's exactly as happy with those K less units than he used to be initially. And same for the wife. I'm giving her K more units, but I'm changing the shape of her indifference curve so that her utility with those K additional units is actually no more, exactly the same as what it used to be in the initial situation with the old utilities and the old rule. The point is there is no way you can distinguish those two solutions. They consume exactly, if you look at this graph, they consume exactly the same amount of commodity 1. They consumed exactly the same amount of commodity 2. And in terms of commodity 3, she consumed K more units and he consumed K less units, but since I'm only observing the sum, this is not observable. So it's pretty clear that if one thing is a solution, the other two, and K is arbitrary. Yes, there is a question. Can you speak up? Yeah, very good point. Excellent, very smart. That's my next slide. Bear with me that that's exactly right. If you take non-negativity constraints, you get much more mileage. That's exactly right. But let me just concentrate on this. This, in a sense, this is local identification. And what you're saying is that if I take into account global constraint like non-negativity, I might be better. I might be able to get more identification. That's exactly right. That's a good intuition. Now, let me first. So the result is something like this. Except that in a world in which you have plenty of private good, plenty of public good, the result is all my concepts, including the sharing rule, identified up to not an additive constant, but an additive function of the prices of the non-exclusive private goods. But here is the interesting conceptual issue. My additive constant, my K, in the general case, it's a function. First of all, it's welfare irrelevant. So if I'm just interested in assessing the welfare of the husband and the welfare of the wife, I could not care less about this K. And that's transparent for the definition. I'm saying in the new world, she receives less, but she has the same utility. He receives more, but he has the same utility. So it's pretty clear that if I am interested just in the utility that they achieve, whether I'm in the first or in the second case, doesn't make any difference. The utility is the same. As economists, if we're interested in welfare, we should just forget about this distinction. We should say, well, we don't care. There are plenty of solutions, but since they gave the same welfare, we should not distinguish between them. But of course, if we look at inequality, they do matter, because it's still the case that in one solution, she gets K less units, and he gets K more units than in the other. So in terms of inequality, it makes a difference. Which brings me back to the question, which inequality are we interested in? We're interested in, so we are in situations in which the same aggregate behavior might be compatible with very different types of inequality of income. However, the inequality in welfare, it's pinned down. So it's exactly the opposite of what you would expect. You know, the standard logic is, I'm interested in inequality of income because that's something that I can recover, that I can observe, whereas inequality in welfare is something that I cannot observe. In a sense, that's just the opposite. The inequality of income I cannot observe, but it's welfare irrelevant. Yes?
Sorry, could you repeat how you pin down the individual utilities when you don't know the sharing of the burden?
So, yes, if you go back to this slide, there is an infinite number of utilities, and in this simple model in which I have three commodities, if I have a solution which is U bar A, U bar B, rho bar, any alternative solution must be of this form, and the new utility has the same indifference curve as the previous one, except that they are shifted downwards by this constant K. And I can do that for any constant K. The U bar is exactly defined. I can exactly recover the U bar. And then I have the family of utilities which are compatible with my demand, which are derived from one another by those kind of shifting upwards or downwards the indifference function. So essentially, I can identify the black indifference curves. And the one thing that I can always do is I take all those curves, I shift them downwards by K units. I have another set of preferences, but they're also compatible with the demand function. Is that clear? Okay, So I have this kind of paradox. Let me come to the previous question, that in addition, I can have global restriction like non-negativeness, and in principle, if you believe in those global restrictions, then you pin down exactly also the constant. And it's easy to see, right? Because if rho is my rho bar plus a constant, I have a restriction like if the income is 0, if the total income of the family is 0, then what he gets must be 0 and what she gets must be 0, but that exactly pins down this, and not only it pins down the function, but it gives you over-identifying restrictions. So your intuition is exactly right. I'm talking about local identification. If I'm willing to look at global identification, then I can do much better. And by the way, some of you, I don't know if you're familiar with the revealed preference approaches. There is so revealed preferences. I just looking at a finite set of data, and the only thing I can say is a given bundle is preferred to another one if I observe that a given person could have purchased bundle A at the current price, but did purchase bundle B. So now there is a revealed preference version of all this collective stuff. There are very interesting papers by Churchier, De Rock, Vermeulen, Lubel, and so on. And this literature in general identify bounds, because in revealed preference you identify bounds, but those bounds can be quite narrow. So you certainly don't find the fact that there is an arbitrary constant of any magnitude. That's not what you find in this literature, but it's because the revealed preference constraints are global constraints and not local constraints. So there is a subtle difference between local identification and global identification. Okay, just as a reward for being patient with me for all that time, here are some empirical results. And let me show you, what kind of stuff has been done in the literature and what did we find. So that's an old paper. It's 94. And that's a paper in which what we're trying to do is we use exactly the framework that you had before. All commodities are private. There are a bunch of goods. In our case, there were 7 or 8 commodities coming from the Canadian Family Expenditure Survey. The exclusive good is clothing. So we have the expenditure of male clothing and female clothing. That's what we used. We use a vector of distribution factors, which are the relative income. So the idea is take two households that have the same total expenditures. In standard consumption model, you don't regress consumption on the income, you regress consumption on total expenditures, and you instrument total expenditures, that's the standard practice. Now, take 2 households that have the same amount of total expenditures, but assume that in one household, the husband income is 80% of total income, whereas in the other, it's only 40%. And you might expect that there is a difference in behavior, and you might expect that this difference in behavior might have to do with the fact that when she's making 60% of total income, she has more power than when she's making only 20%. That's exactly what you want to capture. You can use functional forms like this. So this is parametric identification. The model is non-parametric identified, but you can use parametric identification. You take quadratic angle curves. This is a quadratic working laser for those of you who are familiar with the empirical literature on consumption. The sharing rule is a fraction which depends on a bunch of observable, including the distribution factors and income. And you can identify the model, and here is what you get. So on the horizontal axis, you have the share of wife in household income, which in a sense is a distribution factor. It should be something that's correlated with her power. And on the vertical, you got the endogenous variable, which is the share of the wife in total expenditure. So how much private goods are spent on the wife's behalf. I'm just looking at private commodities, so you should think of it as a conditional sharing rule. There are public commodities in the FAMEX that we don't use. So what you see is that, first of all, it's increasing with the wife's power. And then also, it's moving a little bit depending on the wealth. So it seems to be the case that in wealthy household, when they have high expenditures, the share going to the wife is larger. By the way, the point right in the middle here, 0.5, 0.5, that's a normalization. Remember, everything is identified up to a constant, so we use that normalization. The shape is identified, but everything can be switched up or down. Second thing, you can do exactly the same with labor supplies. So that's a paper with Fortin and Lacroix in 2002. You use standard form for labor supply. You can compute the sharing rule and everything. And you got results like this. So just look at the column which is here, which is the coefficient of the sharing rule. And the sharing rule, so remember the sharing, the story with labor supply is you take non-labor income, there are transfers. By the way, remember one thing, I'm assuming efficiency. Efficiency means the transfer is not a taxation. The transfer cannot be, I'm receiving 50% or even 20% of your labor income, right? Because if that was the case, it would mean that the price at which I'm selling my leisure is not the wage, it's the wage minus 20%, and that would be inefficient. That would be a distortion which would violate efficiency. So, which is, in general equilibrium, when the second welfare theorem tells you if you want to decentralize an efficient allocation, you do that with lump sum transfer. You're not allowed to change prices, right? So it's a lump sum transfer. But you can ask questions like, assume that our wage is increased by $1, what fraction of the additional income will go, what's the impact in terms of transfer to the husband? Assume that his wage is increased, what amount will be transferred to the wife? Assume that non-labor income is increased, now the kind of result here is something like out of each dollar of non-labor income, 70% goes to the wife and 30% goes to the husband. When the husband wage is increased, he keeps most of the additional gain, whereas when the wife's wage is increased, she gives a large fraction of this to the husband. And those things are sort of interesting. The sex ratio and divorce laws at the bottom. Now, this is coming back to this idea of distribution factor, that there may be factor that have an impact of the respective bargaining position. And we use two of them. We use divorce laws, so we have a sample of people, and those people are in different states, and the laws governing divorce are completely different across states. So you would expect that in places in which divorce laws are very favorable to women, they should be better off. Now remember, what do we mean by better off? She should be able to attract larger lump sum transfer. In terms of labor supply, leisure is a normal good, so if she is able to attract a larger amount, she will work less. So in those states, you would expect that she works less and he works more. And the other thing is the sex ratio. That's the old idea. We're going to come back big time in the second part of the talk, but it's the old idea that if you're in the world, if you're in a context, and context I mean state, race, and age. If you're in a context in which there is a considerable excess supply of one gender, so let's assume that you're in a situation in which there are much more women than men. And there are some states in the US in which, in particular in the black population, there are 60 women for 50 men. So you can have huge imbalances. You would expect the bargaining power of the husband to be larger, so you would expect the husband to be able to attract a larger fraction of resources and therefore to work less, and she would work more. And that's exactly confirmed by the data, and we can quantify all this. You can read the paper, it's in the reading list. Third paper, a paper in the ARIS stud by Jeremy Lees and Shannon Seitz. Now, they're using a different type of identification, which is slightly different from the one that I was talking about. They're using preferences of singles. They're assuming that there is something which is common in the preferences of single and couples. So the US that you see here is the preferences of couples, which depends on the public good. But the US has a sub-utility VS, and the sub-utility VS is the same as the sub-utility for singles. And they're using these to identify. Now, what they show is that if you do that, you identify exactly, not up to a constant. Again, you can read the paper, it's in the reading list, but here is the kind of stuff you get. So let me comment a little bit on this diagram. First of all, the line which is in between here. So this is UK between 1970 and 2000. And there is this well-known fact that inequality increased a lot in the United Kingdom especially between 70s and 90, which you see, that's inequality between households, the kind of stuff that you can directly measure. And you see that in terms where they use the variance of log consumption, and it moves from less than 2.5 to more than 4. Huge increase in inequality. And there is some increase after all. It's less steep, but there is some increase. This guy here is inequality within the household, and this you cannot observe, but you need to derive using the model, but that's what they do. And what they argue is that at the same time there has been a huge decrease in inequality within the household. Well, this is due to the fact that there is another big change over the period, which is women are getting more and more educated, and they are working more and more. And that, of course, completely changed their bargaining situation. And what they estimate is that the intra-household inequality decreased a lot. So they have two conclusions. The first conclusion is that if you just look at inequality between households, you miss a large part of total inequality. And actually, in the 70s, you are missing more than 50% of total inequality. The between household, the inequality across household was less than 2.5, whereas it was much more than 5 in reality. Lots of inequality is hidden within the household, and if you miss it, you might miss the big picture. That's the first message. But the second message is the message about the evolution of inequality can be completely flawed if you just look at between household, because what you have here is that between household it increased a lot, within household it decreased a lot. So if you look at the inequality across individuals, pretty much it was flat. And the inequality now is pretty much the same as it used to be in the 70s, but for completely different reasons. It's the mixture of two completely different phenomena, one that's well known and the other one that's usually completely ignored. And the last empirical stuff that I want to show you is, so that's exact, I'm just repeating what I told about the notion of equivalent scale and different scale. And the paper of Dunbar, Lubell, and Pendacourt, which is also in the reading list, which is AER 2011, they replaced the assumption that I presented you earlier on with another assumption, which is the so-called scaling variance, which assumes that the sharing rule is proportional to income. Read the justification, but you get a lot of mileage, and actually the only restriction you need, remember I used to make this kind of very strong assumption that the utility when single was the same as the utility when married, and this is very hard to swallow. What they show is that you need a much milder assumption, which is that if you look at the sub-utility of parents regarding their own consumption, it does depend on the fact you have children within the household, but it does not depend on how many children you need in the household, you have in the household. And by the way, you can even weaken this if you have distribution factors. That's a new paper. But anyway, look at this. This is my last table. So you have families, this is Malawi data. We're talking about very poor country, one of the poorest country in the world. You have family with 1 child, 2 children, 3 children, and 4 children. And look at the last 2 columns. The last column is the poverty rate, is the percentage of people below the poverty line as defined at the household level. So this tells you, if you look at family with 1 child, 85% of them are below the poverty line. This tells you nothing about what's going on within the household. Now, with their technology, they can say something about what's going on within the household, which is the next to last column. And so here you got the man, here you got the woman, and then you got the children. And what you see is that this 85% gives you a very contrasting picture. Actually, 85% of the household are below the poverty line, but if you look at men, only 70% are below. If you look at women, 76% are below, and if you look at children, 95% are below. So decided that 85% of the household are below the line completely blurs a basic remark, which is that there is a huge inequality within the household in favor of the men, and the victims are women, but also mostly children. And so and in particular, if you increase the number of children, you don't see much on the men's level. The percentage of men below the poverty line doesn't move much. However, the women, the situation of women, especially of children, deteriorates a lot. This is obviously crucial. You want to think in terms of future inequality. You want to know how the income is allocated within the household. The message here is we have a technology that allows us to look into those issues. I'm done with the first part of my talk. Do you have questions? Yeah. Yes, can you speak in the mic, please? I can't hear you.
So the question I wanted to ask was about, in your view, the best study of the consequences of the gender disparity in the market, so to speak, for African American women. I presume that it's generated by incarceration, the disparity you referred to?
Can you rephrase?
So the issue is about African Americans. You had made a comment about the gender imbalance, which I assume is generated by incarceration.
Yeah.
So the question,
Look,
or no?
Yeah.
Yeah. So the question's the following, which is, if I have a disadvantaged population, one possibility is that incarceration is eliminating otherwise desirable mates. The other would be that the lower tail is undesirable and incarceration is irrelevant. Has that been explored?
Yes, so we did explore that in the paper with Fortin and Lacroix, and we did explore that in a way that we didn't find very satisfactory. Essentially, we look at the sex ratio, and it was something like a reduced form. The model was structural, but there was a reduced form, which is we find that in those sub-markets in which there is an excess supply of women, it seems to be the case that there is inequality against women, that they work more, everything for a given wage, and so on and so forth. So in terms of reduced form, we do observe that. But what's exactly the mechanism? How does it work? The serious way of answering your question will be, let's construct an equilibrium model in which those kind of inequality is generated as an equilibrium condition of some kind of matching model. In other words, what I've said so far is there is some kind of inequality, there is some kind of power, there are some kind of Pareto weights of sharing rule. They are what they are. Can we read them by looking at the data? The question you're asking is a deeper one, is do we have a meta theory about how those inequalities are generated? And that's an excellent transition to the second part of my talk, because the second part of my talk will be exactly about this. Okay. So if you bear with me until the second part, hopefully there will be an end. I will not be answering the specific question about the black population, not because it's not interesting. We're working on this right now, at this moment. I mean, my co-author and are working on this right now. And I hope at some point that I will have first estimates on the white versus black population. Unfortunately, we don't have them. But I can tell you a little bit about how we can address the question.
Thanks.
Okay, shall we take a 15-minute break? Oh, yes?
Sorry, just given this last table you showed, have there been any attempts to include children as agents in the model so they have their own utility function? And I mean, is that just an identification problem, or why hasn't that been considered, I guess, in this model?
So from a theoretical, so the question is, children, do I just consider them a public good, so we make decision on them and they have nothing to say, or do we consider them as decision makers? Of course, there is a related question, which is quite fascinating, which is, can the data tell me whether children are just public goods or they are decision makers? The very surprising thing is the answer is yes. The data can tell you that. So in other words, if you look at the data the right way, you can distinguish between a model in which children are taken care of by the parents but don't have their voice in the decision process from models in which they are decision makers. And I don't have time to give you the details, but I will be more than happy to give you, send me an email to give you all the references. To the best of my knowledge, this has been tested in, not been tested much, but there are a couple of empirical studies that try to test that. In particular, there is a paper by Fortin, Lacroix, and Dauphin, where you're testing that with data from African countries. I think it was Burkina Faso. And there is the PhD dissertation, unfortunately unpublished, of a student of mine who used Turkish data. And what he found, my students, which is something that I know well, he found that if you take, there is an age threshold, that if you take children less than 12, you don't reject the fact that they are just public goods. But if you take children, male, especially in the case of Turkey, male children aged more than 12 or 14, then you reject the fact that they are public good. You must consider them as decision makers. Now, unfortunately, he got an offer from Oxford, but he got an offer from a consultancy in which the wage was something like 5 times what he would have received in Oxford. And quite stupidly decided to give up academics and to go to the consultancy. So the paper has not been published, and maybe it will be published sometime. But I can give you the reference. I mean, I can send you the dissertation if you're interested.
Thank you.
Thank you very much, and see you in.
Thank you.